much grown up with, playing with numbers. And obviously, when we look at numbers, we look at numbers in the form of decimals, fractions, and sometimes percentages. To look at, giving you just some practical examples, what we look at is where do you look at percentages? Sometimes we talk about percentages when we talk about, giving statistics. Or, for example, I say, you know, um, 94% of people in the UK actually start a conversation by talking about the weather. Now, this is something that we know, it happens quite, regularly. So here in this case, what I've done is I've used, say, for example, um, uh, you know, a percentage which I've read somewhere, and I've used that essentially to be able to, talk about it or maybe give some examples about it, to the people or the person I'm having a conversation with. So sometimes you use percentages to say, 50% of the time, or I'm generally on time to the office in 50% of the cases. So obviously, you are describing some information by using some data which has been researched, which has been published, or which you are aware of, and you want to give it out or speak about it, in a number format, and that would typically have examples of percentages in some cases to say or convey that information, and that bit of information which is primarily done in this format and in this manner actually uses what is called percentages. Now percentages could also be used in a variety of other ways. Sometimes you look at your grades of your children, how they've scored in the maths exam or the science exam or chemistry exam. You'd say, oh, he scored 70%, 80% of, you ask him, how did your test go? Or you ask your daughter or your son, how did your test go? Yeah, I think 80% I answered all my questions correctly. I should be looking at getting about that much marks. So people generally talk about, percentages in the context of actually, so I would, if I were to ask a question that why do people, talk by using, say, percentages, you would generally get a response, or probably you will understand that sometimes quoting numbers or lots of numbers can be confusing. So use of percentages here can actually be very clear. It can help you express maybe whatever you are trying to do. Say, for example, numbers, proportions, weight, or any changes like, I've seen a 50% change in that person in his attitude. So what you're trying to depict is you're using percentage essentially to essentially communicate something which is going to be much more effective in terms of understanding. If I say, I've observed him for a couple of months, and in month one his behavior was this, in month two it was this. So you're giving a lot of information. Sometimes you have to summarize the information. So in some cases, after summarizing, it is easier for you to actually talk in percentages, and that is what makes the use of percentages, very common in our interactions. So percentages essentially can be used for comparisons. Sometimes I say, okay, I think this company's product is 50% better than the other company's product. So essentially, when we are using percentages, what is the practical application of studying this particular topic? That is what I'm explaining. So when we look at fractions, decimals, and percentages, I've started with percentages. So percentages make it easier for us to do comparisons. A company A is better than company B, or their products are better than, generally their products are much better than the other company. You might highlight the growth of a company or the increase in turnover or profitability of the company, saying, Unilever grew by 50% or 10% this year as against Procter and Gamble. Now, percentages can also be used to look at talking about standardized data, right? Standardized data could be that, when we talk about, like, when we had COVID, so a COVID test when people were doing, so if the COVID test came out positive, then it was understood that, you have contracted COVID and you have to self-isolate. So the government used to put out some statistics or figures at the end of every week to say, 70% of the population has now been vaccinated, or 20% of the adult population has now been vaccinated. So percentages help us also to talk about data or information in a very standardized manner. It becomes easier for us to interpret the information across different contexts in which it is being communicated. Now, percentages sometimes also helps us in clearly communicating proportions. Now, if you think of places where you use percentages, so sometimes you would say proportions. If you're making something in the house, for example, you're making a cake and you want to bake a cake, then how much cake? So, for example, if you're wanting to make a chocolate cake, or you want to make a vanilla cake, and the icing or the flavor that you have to put, you would not talk about proportions. If you have to mix something and make, for example, in a food recipe, you would talk about in proportions. So you mix 2 balls of flour with 1 ball of vanilla and 2 teaspoons of vanilla essence, then that would give you a batter that will help make a cake which will be a vanilla cake. So you talk about in proportions, but that is where sometimes it's difficult to generally classify percentages, but people can also use percentages and proportions interchangeably. So I say 2 bowls. If you are using 3 bowls in total, if you're using 2 bowls of flour and 1 bowl of bowl of, say, for example, casting sugar, then you're saying, okay, 50% has to be flour, 25% has to be sugar, and the 25% has to be rest of the ingredients. So here again, we're talking in percentages. You can talk about percentages in other contexts as well. Things like you show a trend wherein you have a graph, it is showing a graph. If I bring across a graph just on the just as an example purpose, for the context of our discussion now. And if I bring a graph in, you would normally have the graph also expressing, percentages or some sort of percentages that are being looked at. So sometimes it is easier said than done when we do talk about, percentages, that this is what has happened, or, that is what has happened. So if I look at this particular graph, and I make this slightly bigger just to give you a perspective. Now, if I want to compare the performance of this company over 5 years, I can talk about it in percentages, saying that there's a growth happening 40 to 60,000. That means it's almost, doubling the growth, 20 to 40, 40 to 60. So it's 50% growth, between year 2 and year 3. As you can see, it has gone up to 70,000. So you would talk about this in terms of, highlighting growth or decline for a company or a product or a service, and that could be also done in the case of, percentages. Sometimes you also look at simplifying numbers, right? If I say government does the census in the country, so the last census I think happened in 2010 or 2020, sorry, and the UK population came out to be 68 million. Now, in the 68 million, if the government has to express this in the form of, say, some sort of a pie chart, to say, okay, we in the population we have, say, if they were to do it on the basis of religion, for example, they might come up with a chart which would probably say, these kind of things. Just as an example, I'm pulling up a chart. So in this case, for example, if the government was to say how a business would need to analyze that, how would the regulatory mechanism which the government has impacts the business. For example, taxes, legislation, indirect taxes like VAT, or some of the other acts in terms of policies which the government introduces, and in some cases, competition. So if a company does an analysis internally to see how they are performing with regards to and how they are getting affected by factors in the market, then they would look at maybe doing a pie chart like this, which will say environment regulations, health and safety, competition, consumer protection, and obviously employment law. So as you can see, they've drawn out a particular pie chart, but they've expressed the relevance of these regulations and factors which are affecting the business in the form of percentages, because it is easier for the data then to be understood. So percentages, can be used in our day-to-day life in a very different way. And some of these, when they are used from a context of providing information easier or making comparisons easier, in some cases, looking at quoting numbers or statistics, In some cases, you look at talking in terms of proportions, showing a growth or decline, or just simplifying some large numbers or data. If you have a table, which shows, for example, customer satisfaction, and you want to express that in the form of, some sort of, let's say, easily understandable data, then again, what you would do is basically use percentages. An example of this that I'll bring across is, for example, just randomly picking up something from Google. What you'll see is that this is a table which basically expresses, percentages, and it says the customer response or the customer satisfaction in terms of, supplier satisfaction in terms of, errors. So if the company was looking at communication with the suppliers, customers, in year one, they had 30% or 50% response rate from supplier. That means they were opening up the emails and, things like that. So again, this could be used as a medium to look at simplifying a lot of numbers that don't mean anything to me. But if the moment I see percentages, it starts to make sense because it is depicting some information in the form of a summary or in a way which allows me to express fractional values or decimal values in the form of percentages, which makes it easier for me to understand. And percentages, if I put it this way, just as a universal fact, they are widely taught and obviously used, and they make they make more sense sometimes when you're discussing about data or numerical data or numbers. And sometimes it is the best way to express, tables, charts, statistics, probabilities. And obviously, if you have complex data which is being discussed, then it will allow you to discuss that data in a much more, easier fashion. Now, the other bit that we want to understand is fractions and decimals. Now, what is a fraction? Any idea? Do you see any numbers on the slide which are basically showing fractions? Any idea? What is a fraction? So if I were
I would
to
say a fraction is just a part of something, a whole, a part of a whole,
right,
or a
so
portion of a whole.
right, okay. So when you do talk about fractions tend to, what you've said is correct. What fractions, if I have to go into a bit of detail, obviously they represent a part of the whole, and sometimes when they depict a part of the whole, for example, if you were to show, a fraction like 7.5, and this is like a number which is having decimals, 7.5, for example. Now if I have to convert that into a fraction, so if I put it this way as an example here, so what, going by the definition that you have said, so what is a fraction? So what you rightly said, a fraction represents a part of the whole and consists of, if I add this to this to complete the definition, it consists of two numbers. What are these two numbers? And I put a bullet point here. One of the number is called a numerator, and the other number is called denominator. So a fraction, if I had example, if I wanted to represent 7.5, which is a number, which is basically a decimal number. So if I wanted to represent this number as a fraction, how would I do this as a fraction? So what I'm going to do is basically 7.5. First, in order to remove the decimal, I'm going to divide this by 1 and put 10 because I'm adding 10. So essentially, this would become 75 by 100 because then I need to remove 0.5. I need to add 10 under the in the denominator. So then this number would become, if I put 7, remove the decimal, this number would become 75 by 10. Now, if I divide 75 by 10, I will still get the answer as 7.5. So the number hasn't been altered, but what I've done is I've used the formula to basically convert the fraction into a number which consists of a numerator. Numerator is on the top, and denominator is at the bottom. So top of that number is called the numerator, the bottom of that number is called the denominator. So if I had to write this, I would write it like this underneath that, and I would write at 10. This would be the numerator and the denominator if I would put a line in the middle, and that is how it will be. Now, if I need to write this as a fraction, how would I write this as a fraction without dividing this, without writing it in the form of a decimal like 7.5 or a fraction in terms of a number, having a number in a decimal? So what I'm going to do is, if I remember the days when we used to, say, for example, do division, the division used to happen, by actually, let's say, doing it in a way wherein the idea was that I wanted to divide the number. So what I would do is essentially create this like this. So I'd write the number 75 here, and then I'm going to divide the number by 10. So if I had to divide, so 10 times 7 is 70. So I'll write 70 here. And then I am left with a denominator which is 5, because 70 take away from 75 will be 5. So how would this become a fraction? So if I have to write this number as a fraction, what will happen is fraction, you will be, what it will be, 7 will come here, 5 will become the numerator, divided by 10. Now, how would this number become equal to 75? So 10, this actually 7 comes in the middle here. So 10 times 7 is 70, plus 5 will become 75 by 10. So I will reach the same number without having to, change any the context of it. But this would then still be the same number, 75 by 10, actually expressed as a fraction, which is going to be 75 by 10. Do you see this? Now, if I had to simplify this number to make it a smaller fraction, so I know that 75 is divisible by 5, so 5 times 2 is 10. And then if I had to look at 75, so it is 15. 15 5s are 75. So 75 by 10, if I had to express the actual value of the number as a fraction, will be 15 by 2. And 15 by 2, if I do divide by that, that will still become 7.5, which is where we started off with the original number here. So depending on the context in which how we want to use numbers, we can express numbers as a fraction, as a decimal, and in some cases we can also express it as a percentage. The same number I can express as percentage. Now, percentage is normally always done, it is always in 100. So percentage always is always, in terms of context, when we talk about in the context of 100%. Now, if I had to convert this same number into a percentage, what I'm going to do is I'm going to convert this number into percentage by multiplying it by, in this case, dividing it by 100. And that would essentially give me the percentage of the number as well. So the same number we can actually express as a fraction, a simplified fraction. I can express this as a number which is consisting of a number in a decimal, and I can also express this number as a percentage. Now, 75 is what percentage? Because it has 3/4 in it. So this would be 75. If I had 7.5 converted into, if we have to, if say, for example, you had to express 7.5, as a percentage in number. So how would that be done? So if I had to express this 7.5 as a percentage, to talk about it in terms of a percentage number, what I would do is multiply 7.5 into 100. That will make it 750, or basically essentially as a symbol, if I had to express it in terms of decibel, then how do I express this in terms of percentage? I would need to know the context of it. So normally when you talk about a circle or a full circle, you look at it from a 360-degree angle. So if I were to draw a circle typically, has 360-degree angle, because you're going all the way around. So if you draw up an axis which is X, and Y. The other way around, actually, this is Y, this is X, and you draw a circle. Then what is the percentage or what is the angle? So here, because this is essentially 90 degree, this, if you go down full way down, it will become, no, this is 45 degree. Sorry, not 90, this is 45 degree. This will become 90. This will become 120. And this will become 180. And then if I go full circle, that will be 360 degree. So essentially what I'm trying to say is there is a way that you can actually draw or discuss a number when you have a number in terms of fractions, percentages, and decimals. Now, where do you get to see this often in day-to-day life? For example, if you go to a vegetable hawker, or you're looking at buying some grocery and you go to the vegetable counter, you want to buy some mangoes, right? And the price on the mangoes or price of the watermelon or anything that you're buying is actually given in terms of kgs. So 1 kg of watermelon is equal to, say, a pound. But normally, when you pick up the watermelon, you have to weigh it and then put it onto a weighing scale. Now, if because of the size and shape of the watermelon, the weight can vary. So what will happen is essentially you would pick up the watermelon, you'll put it on the weighing scale, and the watermelon comes out to be 4.34 kg. I'm just picking up a number, 4.34 kg. Now, how would you calculate the price of that watermelon? You know that 1 kg costs, for example, 1 pound. So how much would 4.34 kg cost? So you would need to use numbers and fractions to be able to do this. So if the watermelon, for example, costs 1 pound, I will write it down and show it to you on a slide, per kg, 1 pound per kg. And then you have to, the melon, say for example, that you are buying is total weight of 4.34 kg. Then what is, you are looking at calculating what is the price of the melon you would pay. So in this case, I need to look at basically finding out what would be the price. So here we are using numbers, to essentially look at what this would be, and you want to quickly calculate in your mind that, okay, what is it that it is going to be? So let's look at, this as a example. Now, when I look at this example, I know, for example, I'm going to look at, this is the question that I've written down. So if the watermelon, or if the melon costs, for example, 1 pound per kg, and the melon that you're buying is a total weight of 4.34 kg, then what is the price of the melon you would pay? Now, how would you calculate this? You would need some sort of a formula, but obviously once you have the formula, you're going to be making use of some decimal multiplication fractions, or expressing it as value to be able to pay to the hawker that you're buying it from. So we know that 1 kg of melon is 1 pound. I made it simple, and then the weight that you're buying of the melon is 4.34 kg. So how would that be calculated? Your total cost is going to be price per kg into total weight of the melon. So that's what I've done, 1 pound into 4.34 kg. That means the total price of the melon would be 4.34 pounds. So here, in this case, what you've done is you've used numbers. You've expressed that number by combining the weight and obviously looking at the price per kg, and you've expressed it into a number, which is a number in a decimal number, which is 4.34. That means you're paying 4 pounds and 34 pennies. Now, you might want to round this off, because you have 5 pennies and you have 10 pennies, you have 50 penny, and you have a pound. But we don't have one. You also have 1 pennies. So assuming if you don't have those as 1 penny, what you're going to do is you're probably going to end up paying 4.50 to the hawker, and what he is going to do in turn is obviously give you a 10 penny and about 1 penny into 4. So he'll give you 14 pennies back, or 16 pennies back. 1 penny will be, one of that penny will be a 10 penny, one of that will be a 5 penny, and then one of that will be a 1 penny, and that you will get 16 pennies back. So this is a way that you are going to use numbers to be able to reach, practical solutions when we are using it in day-to-day life. So expressing your answer in terms of the way that you would pay for the product or the service that you're buying could be done in the form of fraction, in the form of a number, which could be a decimal or a fraction, and sometimes in the case as percentages. Example, another example that I would say is, for example, you would want a gardener to come and sort your garden out because of the fact that now it's spring. There's a lot of grass and other bits which are overgrown. One of the questions which your gardener will ask you before coming would be that what is the size of your garden, right? The other question would be, well, the reason why the person would think about, if you put your thinking hat on and think why the person would want to know the size of the garden, because it could be one that he needs to buy the weedy side, to be able to put into your garden. So he wants to calculate what is the total area of the garden. So total area of the garden, and basis the total area of the garden, he will essentially buy, the weedicide or some sort of a, spray that is going to help remove all the weeds from your garden, and but also will help the grass to go. So for example, he wants to buy manure bags, or bags for organic uh, you know um, um, matter, for example, to help the grass grow. So he would need to know how many such bags would be required, what kind of weedicide he should get, whether he should get a half a liter, 1 liter, 2 liters of it. Now that will all depend on the area of your garden. Now in some cases, sometimes you don't know the exact area, so you're going to say, I think it's roughly. So your answer might be, I say, for example, I would say I don't know the exact size, but roughly, the size of the garden, for example, it is 12 feet long, and you would say approximately, and approximately 10 feet wide. Now, what he's going to do is, obviously he's going to calculate the length of the garden, the area of the garden. And area of the garden that he's going to calculate is going to be on the basis of the length and the breadth that you're given. So length, because it's like a rectangle, length into breadth, which is the formula, equal to, so you mentioned 12 feet by 10 feet. That means the garden is roughly 120 square feet. So for 120 square feet, what he's now going to look at is what could be the percentage in terms of weedicide that he needs to spray to get rid of the weeds, and what could be the number of bags that he needs to get to ensure that he can fertilize the soil or maybe help the grass to grow. Maybe bring some manure and things like that. Now, this is going to be, he obviously goes to B&Q, for example, and he would then need to buy that. So when he looks at the bag of or the weedicide bottle or the bag, the mud bags and things like that, he sees that, okay, one bag is 10 kg. And then it'll on the bag also give some instruction that this 10 kg feed is good enough for a garden size of, say 3 square meter, or 10 square meter. So he'll roughly have a figure that if I'm looking at 10 square meter, 10 by 10 is about 100 feet. So I would need about one bag as a minimum feed for the garden to be completely, say for example, the feed to cover the complete garden. And in such cases, what you're going to be using is, you're going to be looking at, okay, one bag would cover almost 90% because it's 100 square feet, and we have an area of 120. So I think it'll cover about 80, 90% of it. So you're talking in percentage. And he would say, okay, he might ring you up from B&Q and say, your garden is, but this one bag covers about 80% of your garden. Do you want me to bring 2 bags? Because that would mean you'll have some of it which will not be used, and it'll be used, as spare, or I could put some part of that feed into your, pots that you have, or, other areas in and around the garden. And you'd say, okay, yeah, how much this would cost? And you say, okay, one bag is 10 pounds, 2 bags are going to be 20. So you say, okay, that would cover up all the pots and all the garden. Yeah, he would say, yes, around about 1.5 bag would be used up in the garden, and the rest which is left, I can do some pots, put some feed onto your flower pots and other things, and that would use it up. So what you're doing is talking in terms of percentages, fractions, and obviously in terms of, easily understandable language. And that is where you're going to see the use of fractions, decimals, and percentages, because mentally you're looking at doing some calculations, and they are going to be helping you to represent a part of the whole. They are obviously used in various contexts. I've given an example of, when you go out and obviously do some shopping, or when you're taking some measurements for doing up the garden. And in day-to-day basis, we look at it in finance and on our day-to-day life, we use fractions, decimals, and percentages in mathematics primarily to represent a part of the whole. Now, another example that I would give you is if you look at a fraction in particular. Now, fraction, as I mentioned to you, consists of two numbers, numerator and denominator. The numerator is the top number, or the number on the top, and denominator is the number at the bottom. And they too then become the actual part of how a fraction is actually, depicted. Now, there are some rules that you also need to understand. So when we talk about fractions, one of the things that you would see in fractions would be the numerator is always smaller than the denominator. Because if you have a fraction like 1 by 1 is actually 1 divided by 1 is actually 1. So if I have to put 1 as a fraction, I would use 1 by 1. If I have to use and depict 1 as a number, I would use 1. And because it is a whole number, there is no decimal, so it will be depicted as 1. But if I have to depict it and talk about it in percentage, if 1 is a number and you have 1 and 0, or binary situation, either 1 or 0, and you talk about 1, it is 100%. Right? If I say 0.5, it will become 50%, because when I depict 1 and take away half of it, then it becomes 0.5. If I have to depict this fraction, what will happen is you'll divide 0.5 and then underneath put a denominator, and then because there is one decimal and one number after the decimal, you have 1 for the point and you put 0 for first number. If you have 2, then this will be 1 and then it will be 1 and it will be another 0 and another 0, because there are two numbers after the decimal. So in such cases, you should be able to understand how to go about depicting a number which is going to be in decimal or in percentages. Now, if I have a number like this 0.5, which is given here, now if I have to represent it as a fraction, what I will do is, because there's a point here or a dot here, for that you have to put 1. Every time you see a dot, you will always put 1. So if I had 0.442, so if I have to express this into a fraction, what I will do is put equal to here. For this part which is having a dot, I will always put 1. And then if you have 3 numbers after the decimal, you will put 3 zeros to express this into a fraction which is going to be a whole number. So now that you have removed the dot and the 0 and the decimals have gone, this number will become 442 by 1000 if you have to express it as a fraction. Right? So in such cases, and if you have to find out the express this number into percentage is always 100%. So you multiply this by 100%, and that will give you this number which you can express in the form of percentage. So that is what has been done on tables here. So here the example is 0.5. If I have to represent it into a fraction, if I'll put dot 1 and there's one decimal after the dot, it will be 10. Now if I simplify this fraction, 5 times 1 is 5, 5 times 2 is 10. So this number 0.5 can also be expressed as 1 by 2, as you can see, which is being given here. So if I had 0.25, so what will happen in 0.25? If you write 0 and you write 0.25, and if I have to express this as fraction, so for the dot I'll put 1, because there are two numbers, I'll put 2 zeros, which is now become a number called 25 by 100. Now I know this is further divisible, so as I say 25 times 1 is 25 and 25 times 4 is 100. So this number then would become a fraction as 1 by 4, which is what is given here. So the same number can be used to depict in fractions, decimals, or percentages, depending on how you are going to put this across in the context of your conversation or use it accordingly. Now, if I was to talk about converting fractions into decimals, how would I go about it? So if I had a fraction like 3 by 8 and I had to convert it into decimal, that would mean in this case, if I have to look at converting this, that means first thing first, which comes to my mind is because numerator is always smaller, which you need to remember, and the denominator is always bigger. That means 3 has to be divided by 8. That's how we do division, right? We put this across like this. Now, because 3 is smaller than 8 and we cannot start, so what we do is first put a point here, because I need to add a 0. So the moment you put 1 point, because you want to convert it into and see whether this is divisible or not, what I will do is first things put a point and bring a 0 here. So 8 3s are 24. So I'll put 3 here. So 24. Okay, take away 24 from 30, that is 6. Now, if I have to now look at dividing, this number 6, again, it is smaller than 8. So in this case, what I need to do is, if I have to look at dividing 3 by 8 and express it in the format of a decimal, what will happen is you have 8 6 are 48, 8 7s are 50, 8 7s are 56. So the next number that you're going to do is you put another 0 and you put a 7 here. That is 8 7s are 56. So 56, and then you're left, take away from 60, you're left with 4. Now, if I have to again look at this number, I put another 0 here. So 8 5s are 40. And then 40 times, take 40 is 0. So now I've divided the whole number, but 3 by 8, if I have to express as fraction, has actually become 0.375. And that has totally divided the number, 3 by converting it into what is called a decimal fraction. So it is 0.375, and that is the answer. And that is how you arrive at it. Now, when you have to look at another example, if you had to divide, say, 2 by 9, you would follow the same process. So if I look at 2 here and then divide by 9, essentially, you'll follow the same process. So how will that work? You have 0 because you cannot divide 2. 2 is smaller. You put a dot and you make 20 here, right? So 9 2s are 18, 0.2, and you are left with 2, 18, take away 2. Then again you put 2 because you put a 0 here, and again you put a 2. So this number will continue forever because every time you take away 18 from 20, you are going to get 2. And then you again go back, it'll again. So this is not divisible, but the answer is going to be 0.222 unless somebody has asked you to represent it into 2 decimal places or 3 decimal places. You'd probably, this will go on infinitely because the number, when you divide and you take away 18 from 20, it'll always come as 2 and it'll never be fully divisible. So in such cases, what you do is you sometimes round this off. You would say 0.22, and you would, if they are saying round it off to 3 decimal places, you'd say 223. If they say round it off to 2 places, it will become 0.23 because you have to round it off. So in such cases, this, because as a number, as a fraction, this will continue forever. This is called a recurring decimal, and in such cases, you would always be asked to round off the number to the nearest possible point. So if they say round it off to 2 decimals, then it will become 0.23. If they say round it off to 3 decimals, it will become 0.22, 0.3. And that is how you would be looking at converting fractions into, decimals. Then the next part that we want to look at is how do we convert fraction into percentages? So again, this is something that you need to remember, that fractions can be easily converted to percentages. Percentages always means out of 100, as I mentioned. So if you have 1, then what is the percentage you want to know? One is whether 1 is 100%, 1 is 20%, because 1 as a number is a whole number and there is no fraction in it. Obviously, it is 100%. But if you are having a number expressed as a fraction like 23 by 100, when it is given as an example here, and you want to find out the percentage of 23 by 100, then what you do is you multiply 23 by 100 into 100. You cancel off the hundreds, and then percentage becomes 23. So in such cases, if you have to look at converting fractions to percentages, now what you have to keep in mind is that your denominator is not always going to be 100, but you would need to convert. Whenever you convert a fraction into a percentage, you have to multiply that fraction given to you by 100, and that would help you convert it into a percentage. Now, let's look at a question here which is given 19 by 50. Express 19 by 50 as a percentage. How would you go about doing that? So first things first, what I'm going to do is I'm going to look at 19 by 50, and that is the number that I need to now express in percentage. So one of the things, as I mentioned, is when you have to convert a fraction into a percentage, every time you have to keep in mind is that you have to multiply that by 100. Right? So if I now simplify this, this is the numerator and this is the denominator, right? So I can see, can I simplify this by division? So 50 times 1 is 50, 50 times 2 is 100. So 19 times 2 is now equal to 38. So if I write it correctly, 38%. That should be your answer, as you can see. So if you have to convert fraction into percentage, all you have to remember is you have to multiply that fraction, whatever fraction is given. If I say you have a fraction like 2 by 3, or if I write it here in using a different color, so 2 by 3, and you have to express this into as a percentage. First thing that you're going to do is 2 divided by 3, which is a fraction, you multiply with that by 100. Now, because 3 and 100 are not divisible, 3 times 1 is 3, 3 times 33 is 99. So what will happen is you'll further go into multiplying. 2 into 100 is 200, and then divide by 3. So this as a percentage, if you have to represent, now you simplify it. 3 times 1 is 3, 3 5s are 15, 3 6 are 18. You are left with 2, you bring 0 in, 3 6 are 18. Then again you are left with 2. So 66.6666 will continue, because every time you multiply, 3 6 are 18, the number will always be 20. So take 18, take away 20 is, you'll always left be 2. So this would become 66.66%. If that has been asked to represent in 2 decimals, you would obviously put 66.7, 66.66. But if you've been asked to round it off, then it will become 66.7 as a percentage in terms of number. So 2/3 of 100. Sometimes we use this in English and we say it the other way around, which is expressing it. What is 2/3 of 100? 2/3 of 100 is 66.6%. If you were talking about another fraction, for example, 1 by 7, then again you have to multiply 1 by 7 into 100. That means 1 time 100 is 100 divided by 7. So again you have to divide and use the 7 times table to be able to go up to 100. So 7 11 is 77, 12 is 84, and 12 9 is 96. So that would mean you would get a percentage of 9.33, because again, when you look at dividing it, you'd probably not be able to. 12 times 4 is always 48, and you have always going to be left with 30. So obviously 12 2s are 24, 6 will be left, and then you'll have 9.375%, which will be that number. So mentally you can do it, but if you have to do it on paper, which is something which is going to come in your exam, there will always be one question or two questions in your paper which will be non-calculator based, and you need to use a pen and paper to calculate the percentage, and you would need to know how to convert a fraction into a percentage, how to convert a whole number or a decimal number into a percentage, and that is where these examples that I'm giving would actually come in handy. There'll be 1-mark questions, and you would be asked to convert a number into a fraction into a decimal, and you'll be asked to convert a fraction to a percentage. And The third type of question that you're going to get is going to be a question related to how do you convert decimal to percentages. So if you have a number which is like a decimal, like 0.42, what is it in percentages? So this is something that you need to remember. When you have a fraction that you have to convert to decimal, you basically would need to divide that number by using that formula or the way I expressed it in terms of division. When you have to convert fraction to percentage, you'll have to always multiply it by 100. And when it comes to converting decimals to percentages, there is always this formula that you have to multiply again it by 100 because we are talking about a percentage. So if you have to convert 0.42 into a percentage, example of that would be, if you look at this as an example, how would you do it? 0.42 into 100. So obviously, because there are two decimals, so what will happen is if this is a point, 10 cancels out one decimal, second zero cancels out second decimal. So this would become 42%, right? If you add a number like, I would say 0.92, and you have to express that decimal as a percentage, what will happen is you'll multiply this by 100. So one test, because there are two numbers after the dot, so one cancel out 10, the other cancel out other 0. This will become 92%. Now, you might get a question in your mind that, okay, what if I had a number like 0.3 or 0.5, say for example 420, and how would I convert this into a, now this is also a fraction, but how would I convert, or sorry, this is also a decimal. How would I convert this into a percentage? You'll follow the same formula. You'll multiply this by 100. Very, very simple. But because you're talking about percentage and there are four numbers here, so you cancel out 10 with 1, 10 with 1. So this will become 54.20%. Rest of the decimal will let it remain like that. But when you express it as a percentage, this will become 54.20. If you add a number like 0.2, say for example 3174, and you had to explain and express this as a percentage, again you'll follow the same rule. What you're going to do is multiply this by 100. It doesn't matter. So when you multiply this by 100, what will essentially happen is you'll have 10 which cancels out here, 10 which cancels out here. So it will become 23.174%. And you put the percentage symbol next to it. So these are bits that you need to remember essentially when it comes to converting, fractions to percentages, fractions to decimals, and percentages to fractions. So they can, in the exam, what will happen is you'll be asked to express certain numbers in different formats, and these would take. There could be one question which will say convert this fraction into a decimal. There could be another question for 1 mark which will say convert fraction into percentages. There could be another question which will say convert decimals into percentages. And you need to remember that in this case, if a number is expressed as a decimal, you multiply by 100. If the number is expressed as a fraction, you multiply that by 100. And that would give you a fraction, or that will give you a percentage. Now, it could be the other way around. If you were given percentage, they could ask you to convert that into a fraction. So how would you convert a percentage into a fraction? Now 25%, if I ask you to convert into a percentage, this is percentage given. If I ask you to convert this into a fraction, what you're going to do is basically multiply this 1 by 100. Because what you're looking at is, you're looking at fraction. Fraction is a number which is expressed as a whole, but it has two parts. So you have to remember numerator and denominator. So how would you get the percentage converting into a fraction? in that case, what you have to do is you have to simply look at converting the percentage times multiplied by 1 by 100. And that's the formula. So you have to remember this. So if I have to convert 12.5 into 12.5% into a fraction, you are going to multiply this times 1 by 100. And because 125, 12.5, you have to convert into a whole number. So what you'll do is, because there's one decimal, so you'll put 125, you'll remove the decimal, but you'll put another zero underneath. So it will become 125 divided by 1000. How would this become? So if I had to do this, for example, this number here, so first part, I will write 12.5, right? And then if I have to represent this as a fraction, I have to multiply it by 100. So that would mean times 1. I've written down the first part, but it will be times 100. So this, if I have to express again, this will be 12.5 multiplied by 1 is 12.5, and then I'll take the denominator underneath, and that will become 100 as I've multiplied 1 by 100. Now, if I have to take this decimal away, what I need to do is I need to add another 0. So taking that away would become 125 by 1000. So then this number is now expressed as a fraction. Now, what I can also do when I'm expressing this as a fraction is that I can simplify this further, because it's both the numbers, numerator and denominator, is divisible by 5. So what I do is 5 times 2 is 10. There is a 2 which is left. Then I bring 5. 5 5s are 25. So this becomes 25. And then divide by 1000. So 5 times 2 is 10. And then carry forward 2 zeros. So 25 by 200. But as I can see, this is further simplifiable. So again, I say 5 times 5, and then 200 is 5 fours are 20. It becomes 40. This is further simplifiable. So 5 times 1 is 5, and 5 times 8 is 40. So this number, if I have to express, as a fraction, 12.5% as a fraction would become 1 by 8 in the simplest form. But because if they don't say simplify it to the lowest possible value, then in that case you would do 1 by 8. But if it says convert 12.5% into a fraction, you could also leave it at 25 by 100, and that would be acceptable as an answer. But generally, when you simplify it and you see the numbers are divisible and they have a common denominator and a numerator that you can divide, then you bring it down to the simplest possible value, which is 1.8. That means if I have to talk about 12.5%, that means it is 1/8 of 100. And that is how you would convert percentages to fraction. So you have to remember this, that when you convert fractions to percentages, you times 100. When you convert decimals to percentages, you times 100. But when it is the other way around, when you convert percentages to, say, for example, fractions, then you would be doing 1 by 100 for the number which has been given. And similarly, when you look at converting percentages to decimals, you'll have to look at dividing each of the percentage by 100 to get the equivalent decimal. So if I look at 42%, because percentage is always, remember what is percentage, is always 100. So you have to put 42 divide by 100, and then you have to arrive at the answer by dividing 42 by 100. And how would I do that? So I would do 42%. And here what I'm going to do is use that same division formula which I normally do when what we have learned in school. So you write 100 here, and obviously 100 is a bigger number than 42, can't do it. So I put 0 because it is not divisible. Then I put a point, and then I bring a 0 here. So now this becomes 420, which is divisible by 100. So 100 times 4 is 400, right? And then if I take away that, we are left with 20. Again, what number is going to be divisible? So I bring another number here, and it is 100 would be 2. So that will become 200. So 200, take away 200, then it becomes 0. That means now this is fully divided. So 0.42 would become the fraction of 42%. So that's how you'd go about converting percentages to decimal, wherein you always divide that particular number by percentage which has been given by 100, and that will give you the fraction or the decimal, sorry, not fraction, it will give you the decimal of converting the percentage into the decimal by dividing it by 100. So that allows you to understand that how do we look at the use of percentages, fractions, and decimals in our day-to-day life, which could be either used in maths, could be used for finances, could be used for measurements. And obviously, when we are going out in situations wherein we are dealing with numbers, whether it's to buy the number of bags of feed for your garden, or when you're buying fruit and veg, or for example, you want to calculate the value of a particular item which is which is given, say, for example, in taking in mind its weight, the size or requirements in terms of measurements, then in such cases you'll also be looking at calculating its value, and that value could be calculated in the form of fractions, decimals, and percentages. So this particular last slide talks about understanding whether this is a fraction, this is a percentage, or this is a decimal, and how would you express that. And these are some exercises or activities that I would suggest that you could do to primarily, I would say, let's say, practice what we have discussed today, with regards to, the topic which is covering fractions, decimals, and, percentages. Any questions on this so far today? So if I show you the Moodle and how do we go about and where is this particular section given on Moodle? So if I look at this topic, when you go into NCFE and obviously go and select maths, obviously there are lots of topics which are given. Today we have covered this particular topic, which is fraction, decimal, and percentages. So when I click on this, it will open up, and this is the presentation that I've shown, which I've used today. That is, that you can refer to. And there are some activities which are basically, there's one activity in particular which has been given to test the knowledge that you've gained from this session. And what I would do is primarily click on this, and this would open up a certain number of activities that I've given. Now, in this table, fill out the missing information. So how do you convert 3/4, which is a fraction, 3/4, into a decimal and into a percentage? And you would have to write these answers. If you had 25%, which is given, how do you convert it into decimal, and how do you convert it into fraction? So this is something that you would need to do in order for you to practice and understand that, in order to practice and obviously understand that this is something that you have, understood. And what I'm going to do is basically also open up the answer, so that at any given point in time, when you cover this on the second page, the first page is the activity, the second page shows you the answer. So what you can do is obviously go in and do this as an activity, and then test yourself to see if you've got the right answers by scrolling down to the second page. Now, the other bit that you can also do, I've got another activity which has been mentioned, and if I click open on this, this is another activity that I've given, and I can open the answer for this activity so that you can go in and test yourself that whether you are getting it right or wrong. Now, the reason I would not want you to go in and actually see the answers first is because that will create a bit of a bias, and you would probably not look at then, obviously doing it, properly. So my suggestion would be to revise what I've discussed with you today by doing these small activities. It will not take you more than 10 minutes, but do it using pen and paper. Do it using a calculator, because what you want to do is understand the methodology in terms of how you would convert decimals to fractions to percentages, and then vice versa, which is percentage to fraction or decimal, or fraction to percentages or decimal. And this particular topic will definitely is a topic which gets 2 or 3 questions in your exam, and it is important that you are able to, it's a simple topic, it's important that you understand how to convert, and this would 100% help you get the marks that is required from this section, which is the easier section as compared to some of the others that we would cover at a later stage. Is that okay? Any questions on this so far? So if there
I
are no
think
more
I have a
questions,
question on
yeah, go
mathematics,
on.
but you always talk of exam. When are we writing it and where?
So exam is going to be, after about 8 to 10 weeks, because we will take, this, there are a number of topics in maths. So what we are going
Okay.
to do is cover all these topics in terms
Mm-hmm.
of our discussion, go through this from a point of view of doing these activities to do a bit of check that you've understood. As I mentioned in the last session, that in the maths exam, there are 29 topics that you see here, from positive, negative numbers to, scatter diagrams. Now, because this is a GCSE equivalent
I don't
exam,
know what did what did
you
they do
need to be
yesterday?
able to at least achieve 55 to 60% marks to pass the exam.
The person
That
don't
is when
forget
you
that
will
one
be
though.
getting the certificate. So if there are 29 topics, I'm not assuming if you're not looking at achieving 100% in the exam. My idea would be to become comfortable with at least 20 to 21 or 22 topics, wherein that would mean that you are 100% sure when you sit the exam, you pass the exam the first time. So before you do the exam in the center, you can go and do an exam or check your preparation for the exam by looking at, doing this particular search. And I'll put this link, on the WhatsApp group. There is 3 practice tests that you can actually do from home to test your knowledge about the functional skills maths exam. So here, what I would do is click on this. I'll send you this link in any case after this session, and there is a way that you'd be able to do these tests from home to check on whether you are ready to actually do the exam. Now, this is for English as well, English reading, English writing, because the speaking, listening in any case happens in the center in a group of 3. So that's a open book exam. But let's look at maths. If you want to do this, you click on this paper and it will launch the exam on your screen. Now, this won't run on the mobile phone. This won't run on the tablet. It has to be a PC, Mac, or a laptop. So when you click on this, what will happen is you'll be able to run this as a practice test at your end. It's a 2-hour exam. It has 2 parts to the exam. The first part is a non-calculator exam wherein calculator is not allowed, and this will be 30 minutes. You cannot go back to this section once you start this. And once you have completed, you can then only start the section B. So generally, my suggestion, that's why I've recommended, that would be when you are doing the practice at home after my sessions and the activities that you practice with. That is why I've suggested don't use a calculator, use a pen and paper to solve this, because when you have the exam, there'll be a 30-minute non-calculator section and there'll be a calculator section. And this would give you a very good idea in terms of how the exam comes. So there are going to be in the section 1, for example, that we start off with is a non-calculator section. There are 6 parts to the exam, and that has to be completed in, as you can see, 30 minutes. So it is a timed exam. There is no way that I can change the time or do the time. And the idea of going through each of these topics is that we are going to understand when this kind of a question comes, what it is asking us to do, because the topics are helping you revise and understand how these kind of questions, what kind of these questions would come related to the topics in the exam. So it is important for us. As you can see, I can't go into section 2 at all until I've completed this or the time has run out. So the idea is we have maths that we use on a day-to-day basis, and things like weight, measures, area, parameter, volume, scale, coordinates, percentages, decimals, ratios, fractions, all these things we use on a day-to-day basis, right? But the main point is we need to be able to just revise, because sometimes when you are in an exam situation, it becomes difficult unless you know the formulas or you know how the calculations are to be done. And that is why we are going through all these topics. So these topics and the tutorials that you're attending are going to help you revise these topics so that you know when a question comes in the in the exam, you very clearly know, okay, this is a question related to decimals, or this is a question I've covered which is related to, ratios, or this is a question which is calculating money or approximation, and you'll be confidently able to answer that particular question. So this particular link for the test, I'm going to put this on in the WhatsApp group, so that for those of you who feel that you are ready or you want to test by just taking an exam, this is what I would suggest that you can do from home as well. So NCFE sample, test papers. And this is both available for English, reading and writing, and maths. And you can do up to 3 of these from home on your PC, on your laptop, on your Mac, and they would allow you to essentially test your skills of where and which topics you are not familiar with or not able to answer. And then some of the tutorials that I'm doing, you are able to cover these with me, and you can ask questions and we can discuss by taking up practical examples or activities which will help you crystallize and obviously become confident in terms of taking it. Now, for some of you, answering your question in short, if you feel you take a practice test, there are 2 or 3, and you feel you know everything, you can straight away call the office and you can come in and do the test from 9:30 to 3 anytime, Monday to Friday, and that would be possible. Not a problem at all. Is that okay? Any questions?
Okay, thank you.
Okay, no worries. So I will send you a copy of this recording on the WhatsApp group, and I will see you guys tomorrow, wherein we'll cover another topic on this topic list as per in the Moodle, and then hopefully, I will also give you some homework that you can do, revise, and do some activity at home. But I will try and give you a homework on the Word document so that you don't need to print it out, and you can open the Word document and write the answers there, and send it back for the purposes of checking also. So thank you so much for joining, and enjoy the rest of your day. And I will see you tomorrow at 9 a.m. for English, and then 10:30 for maths for those of you who are doing maths.
Thank you very much. Thank you.
Thank
Bye.
you.